All right, so let's continue what we just discussed yesterday. Now, I just want to ask a few questions. For example, if you have 1,000, now can you put this into a
10 to the power of 3.
10 to the power of 3. Now, if I have, say, 3 to the power of 4, what does it mean?
3 to the power of 4 is, so 3 times 3, that's 9. And then 9 times 3, that's 27. And 27 times 3 is 81.
Okay, so see, basically 3 to the power of 4 equals to 3 times 3 times 3 times 3, yes? So you have 4 3's here, yeah, 4 number, and you multiply them. Now, what I want to discuss with you today, it's called prime factorization. The first thing that I want to remind you is something so-called prime numbers. Do you still remember what they are? Prime numbers.
1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
No. Oh. Actually, prime numbers. So this is a number that has only 2 factors, meaning that the factors are only 1 and that number itself. Okay, so the number that has factor of 1, yeah, of 1 and the number itself.
Okay.
Now, for example, if you look at the number 2, so we can get this number by multiplying 1 and 2. And there's no other multiplication that can give you 2 from integers like this and this here. For example, if you look at 6, so basically 6 can be 1 times 6 and 2 times 3 or 3 times 2. So basically 6 is not a prime number because...
Oh, I remember this. Okay, yeah.
Because 6 can be 1 times 6
11.
and
11 is a prime
3.
number.
Yeah. Okay.
11 is 1.
So the first prime number that you need to know is this number 2. That's the first prime number. Yeah. Now it is interesting that 1 is not considered as prime number. Yeah, 1 is actually not prime number. Yeah.
Why?
Well, actually, if you look at the definition, yeah, the prime number has to be 1 and the number itself. Therefore, if you have 1 times 1, now what happens is...
That's the number itself.
Okay, so I think I need to find the explanation, better explanation for 1, why it's not prime number. Yeah, but it's an interesting question. Okay. Now, in this case, if you look at what we know about prime numbers, yeah, actually it started from 2.
Okay.
So 1 actually is not a prime number. Yeah, 1 is not a prime number. Now
7 is a prime number.
7 is prime number, of course. 7 is
a prime number.
Okay, but wait, do you think after 2 we still have another prime number?
Yes.
What's that?
3.
3. So these are the example of prime numbers. Yeah, 2 times 3, and then after that, what do you think another prime number?
5.
5. And then
7.
7. And
11.
11. 13, yes.
Yeah.
17. So wait, do you think 15 is a prime number?
No.
Okay, why is that?
Because it can be 3 times 5.
Okay, that's good. So 15 is not prime number. Yeah. Now, what is the next prime number after 17?
The next prime number after 17 is 23.
No, actually, there is another smaller number after 17.
22.
No, 22 is not a prime number. What's the next after 17?
Is it 19?
19.
No, it isn't. It can be. Oh yeah.
19 is a prime number. Yeah. And after 19,
23.
there will be 23.
And then 27.
No, actually 27 is not prime number. So what is the next prime number after 23?
The next prime number after 23 is not 25.
Not 25.
Not 24.
Not 24.
26.
Not 26, because 26 can be made from 2 times 13.
Oh yeah. Isn't it it should be 27.
No, 27 can be made from 3 times 9. So that proves 27 is not prime number.
28.
28 can be made from 4 times 7. So it's not prime number either.
Is it 29 then?
Yes, 29 is the next prime number. So actually, you can add the list of the prime number and it will give you like very long list. Yeah. In fact, now we can't know the biggest prime number in mathematics. Okay. Yeah. So basically, there will be like infinitely large five number. Yeah. Okay. But you need to know the importance of what prime number is. Yeah. So I guess you don't need to remember all of this. Yeah. But maybe some of the smaller, prime numbers, they're quite important. For example, from 2 until maybe 19. Yeah. So 2, 3, 5, 7, 11, 13, 17, 19. So why they are important? Because what happens is actually you can create any other numbers from prime numbers by multiplying them. So what I mean by that, for example, if you look at the other numbers which are not prime numbers, yeah, say you have 4. So this is definitely not a prime number because 4 can also be made from 2 times 2, right? So in this example, you see that you can make this number by multiplying 2 times 2. Now, if you look at the other numbers, for example, 6, they can be made from 2 times 3. Yeah. And then if you look at the other numbers, say 8, they can be. No, what I'm trying to do now is to get this number by multiplying some prime numbers.
Oh, okay.
So in this case, okay, you can say this is 2 times 4, but now if you look at this number 4, it is made from 2 times 2. So basically 8 is equal to 2 times 2 times 2.
Oh, 2 to the power of 3.
Yeah, so actually what I want to show you here, you see, for example, if you have 4, this is 2 times 2, or you can write it as 2 to the power of 2.
Okay.
And then if you look at this number 8, this is 2 times 4, or 2 times 2 times 2, that gives us 2 to the power of 3. Yeah. So now, you see, if you look at the other numbers other than prime numbers, yeah, we can write them as the prime number times the other prime numbers, or even prime numbers to the power of something. Okay?
Okay.
So what we are doing here.
Hey, that's a prime number to the power of a prime number, and that's a.
Yeah, well, it doesn't have to be to the power of prime number, because if you look at, for example, 16, you see 16 is equal to 2 times 2 times 2 times 2, right? And this is 2 to the power of 4, and 4 here is not a prime number. Okay? Now, what I want to show you here is what we are doing here is called prime factorization. So factorization means you try to have the multiplication that give you this number. So for example, if you have 6, you have 2 times 3, meaning that 2 and 3 are the factors of 6.
Okay.
Now if you look at here, 8 equals to 2 times 4. That tells us 2 and 4, they are also the factors of 8. Now, if you look at these numbers, actually you can also say that, for example, if you look at 6 here, 1 and 6, they are also the factors of 6. And if you look at 8 here, 1 and 8, they are also the factors of 8. Okay? So now when you say the factors, means these are two numbers that can be multiplied and give you certain numbers, right? So for example, if you look at 9, this number has some factors, all right? The first two, of course, 1 and 9 itself.
Yeah.
And then 3 times 3. So 3 is also the factor, because when you multiply 3 times 3, they make 9. Now, what about 16? What are the factors of 16?
4 times 4.
So 4 is a factor of 16, yeah?
And 1 and 16.
1 and 16, very good.
Is there one more?
Yeah, actually 2 more.
2 times 8.
2 times 8, so 2 and 8, they are also the factors. Okay?
5, 10,
No, that's all. Now let's look at the other example to get some factors of it. Let's say 24. What are the factors of 24?
6 times 4, 3 times 8, 12
3,
times 2.
8, 4, 6,
12.
12, and 2.
Yep.
So when you write down these factors, they have to be in pair. Yeah.
Yep. And 124.
124. Do you think we have some other numbers that can give you 24 other than this?
No.
No. Okay. Now let's get 28.
Okay. 4 times 7. 4 times 7. 3 times 14.
Mm-hmm.
1 times 1 and 28. Is there any more?
No. So now you know the meaning what factor here, because you see, if you look at other numbers other than prime number, they can have several some factors. Yeah, as long as when you multiply them, give this number, they become the factors. Now if you look at, for example, 24, yeah, and then now you want to do so-called prime factorization. So basically you try to
get all of the factors that are like prime numbers.
Yes. Now how do we do the prime factorization? That's what I want to discuss with you. Okay, so this is actually not difficult. Yeah, that's why in the beginning I explained to you about the prime number first. So you need to remember now some important prime numbers from 2, 3, 4, and then 5, yeah, and then 7, right, 11, and the rest, yeah. Now when you want to do prime factorization, yeah, we'll try to divide this number by some prime numbers. Okay, we try to divide this number 24 by some prime numbers, but we will start from the smaller one.
2.
Okay, so look at this. Yes, we will start from 2. So let's divide this 24 by 2. Now this is just normally when I do the prime factorization, I do like this kind of calculation. So when you do 24 divided by the first prime number, which is in this case 2, so what does it give you?
12.
12. Okay. Now when you look at the next 12 here, the next number, is it still possible to divide this number by 2?
There's another
Yes.
prime thing.
So when you divide 12 by the same prime number, which is 2, that gives you 6. So the goal here is to divide by the same prime number, yeah, again and again until you can't divide it by the prime number. And when you can't divide by that prime number, you will move to the next bigger prime number. So, okay, so in this case, if you have 6, now what is 6 here? When you divide by 2, 3. So you see, this is the final, the end of it, because 3 is already a prime number, right? Yeah. So if you look at this one now, I can write down that 24, it equals to, see, you have 1, 2, 3, and I mean, you have 2 times 2 times 2, yeah? Look at this. Yeah. 1, 2, 3, yeah? 1, 2, 3, and then lastly we multiply by 3. Okay, yeah. So this is called prime factorization, meaning that you try to express the number in terms of its factor, which are prime numbers. Yeah, so 24 equals to 2 times 2 times 2 times 3.
Which is 24.
And they give you 24. Now the other way to write down this, you can write down also that 24.
To the power of 3 times 3.
Very good. Yeah. Now let's do some other example. So let's say I have 32. Let's do prime factorization now for 32.
32 divided by 2 is
okay.
16.
It's 16.
16 divided by 2 is 8.
Mm-hmm.
8 divided by 2 is 4.
Yes.
4 divided by 2 is 2.
That's the end.
Oh.
That's the end because this is already prime number. So if it's prime number, we don't need to continue. In fact, that's the end of the story. So now you see, we have how many tools here?
4. 5.
5. And that means you can now write down 32 equals to 2 times 2 times 2 times 2 times 2, like this.
Or you could do 2 to the power of 5.
So yes, that's correct. 32 equals 2 to the power of 5. So these steps are very important. Now look at this. This is how I did this when I was younger. And you know, this is quite easy to look at the prime factors. Yeah, when you divide a number by a prime number. Now let's do one more time, yeah? What about 1000?
Okay. 1000 divided by 2 is 500.
Okay.
500 divided by 2 is 250.
Yes.
250 divided by 2 is 125. And that's the end.
No.
Oh wait, oh yeah. You can still do
so now my question is it possible to divide 125 by 2?
Yes.
Why?
63.5.
No, we have to get a positive number. We have to get an integer actually, yeah?
Okay.
So it's not a fraction.
You can divide it by 3.
Wait, so what do you think? Is it possible to divide 125 by 2 and gives you an integer?
Like a full number, like not 0.5 or something.
No.
Okay,
Is it possible? No. Why is that? Why you can't divide 125 by 2?
The end is an odd number.
Okay, that's the answer. Because this 125 is an odd number. Yeah, and you cannot divide odd number by 2. Okay, so if you cannot divide by 2 now, yeah, what is the next prime number? 3. So the question is it possible to divide 125 by 3?
I don't think so. I don't think so.
Yeah, you cannot divide 125 by 3, yeah? Actually, the way to look at it is quite easy, because if you look at this number, so if you look at any number and then you try to add all of them, yeah, for example 125, when you add all of them, they give you 8, right?
Yeah.
And this number 8 is not a multiple of 3. So when you add all of this number and that doesn't give you a multiple of 3.
It's a multiple of 2.
No, look at this. This is how you see if a number can be divided by 3 or not. Okay, can be divided by 3 or not. So this is the rule. If you want to know a number can be divided by 3 or not, there is a rule for it. The first thing is you have to add this number. So 1 plus 2 plus 5, and that gives us 8, right? Now you see, can we divide 8 by 3? No. So if you cannot divide this number, yeah, 8 by 3, that tells us this number 125 cannot be divided by 3.
Okay.
Now, for example, now you see why 27 can be divided by 3?
Because it's 3 times 9.
Yeah, but the reason for it is simple, because if you now add 2 plus 7,
that's 9.
That's 9, and 9 is a multiple of 3.
Okay.
So when you add all of this number and that gives you a multiple of 3, that tells us this number can be divided by 3. Okay, so 125 turns out cannot be divided by 3. That means you have to move to the next prime number, which is 5.
It can be divided by 5.
So what is 125 divided by 5?
25.
25. Now, when you have 25, that's not the end of the story, because you can. Okay, so let's divide this by next 5. 5. And see, when you end up like this, when you end up with a prime number, that means you stop here. That's the end. Yeah? Now let's count. Let's count. How many 2's we have here?
3.
1, 2, 3. Very good. And then how many 5's?
3.
Okay, so in this case, I can write down the prime factorization for 1000 equals to 2 times 2 times 2. See, because you have 3. Yeah. and then you multiply by
50.
5 times 5 times 5. See, we have 3 5s here also, right?
Okay.
So this
Or
is,
you could write it like this: 2 to the power of 3 times 5 to the power of 3.
that's correct. So this is called the prime factorization. Basically, you try to express a number in terms of the prime numbers to the power of something, and you can multiply to it
Always
also.
gonna be to the short way of always writing it is gonna be like something to the power of something.
Something to the power of something, and the number that you take power of it, yeah, it has to be prime number. By the way, this number that you take power of the number, yeah, it is called the base.
Yeah, I saw that in the book.
Oh,
yesterday.
okay. So
Power man to base.
look, when you learn about this stuff, of course, this is just very basic thing, yeah, and you will see the use of it later. You will see very soon, yeah. So I guess that's for today. Yeah? We learn about something so-called prime factorization, and you will learn the use of it. Okay, all right.